Have you ever seen a headline that says X causes Y and something about it feels off? Watch this video to see what a confounder is and how it can completely fake a cause and effect story. Here's the trap. We see A rises at the same time that B does and assume A causes B. In our example, A is coffee and B is heart disease. So it looks like more coffee means more heart disease. In reality, though, C is the real culprit. In our case, the hidden third variable is smoking cigarettes. Smokers drink more coffee, so smoking is positively connected to coffee. At the same time, smoking can damage the heart, so the apparent coffee-heart disease link might be a mirage created by smoking. If we only observe A and B, it looks like coffee causes heart disease. The true relationship only reveals itself after we account for C, smoking. C is what we call a confounder. It's a third hidden factor that is related to A and also affects B. Confounders distort the story and make you blame the wrong cause. In our example, once you compare people with the same smoking status, smokers with smokers, non-smokers with non-smokers, the coffee effect can shrink, disappear, or even change direction. So how can we avoid confounders messing up our research? You need to consider multiple methods that make the coffee groups comparable on smoking, so smoking can't fake a coffee effect. In a randomized trial, random assignment tends to spread smokers evenly across the groups, so smoking is less likely to bias the comparison. In observational data, you can also use matching by pairing coffee drinkers with non-drinkers who have similar smoking behavior, so you're comparing like with like. You can also use stratification by analyzing smokers and non-smokers separately, which keeps the comparisons within more homogeneous groups. Another method is statistical adjustment, which uses models to account for confounders at the same time, estimating the coffee-heart disease relationship after those influences are held constant. Different tools, same goal, prevent the hidden third variable from distorting what looks like cause and effect. Let me summarize. A confounder is a hidden third factor that is linked to your exposure and also affects your outcome. That's why coffee can look like it causes heart disease when smoking is the real driver. Control confounding with randomization, matching, stratification, or statistical adjustment so you don't mistake a coincidence for a cause.